Hey, hi, hello, welcome back to another video. If you're new here, I'm Deepak and I'm a software engineer based out of India. And in this video, we are just continuing whatever we left on the last two videos, which is we are continuing SQLAlchemy model. If you're not watched the previous two videos, actually previous three videos, there is an engine making, then we discuss about SQLAlchemy basic setup, model setup, and relationship, how to define the relationship in SQLAlchemy model. To continue that, there is one more argument is lazy loading. So we are going to explore what is a lazy loading means. So let's start up and let's launch our IDE. So I'm going to create another folder here or file here. It's part 3 and I need a package here. So I don't need this file. I'm going to create another file called main.py. Okay, you can name whatever you need. I'm just going with the okay, and a readme file also, so that we can explain what is there. So what is lazy? That's the first question we obviously we need to answer. In all our video we start with what is that? What is lazy? It's just a parameter that we given to their relationship, and it's like what is lazy in a simple terms, in a 5-year-old terms will be you have a big toy box with many toys inside. The lazy argument will decide when to open the boxes and look at your toys. So it simply says when to look at the data or when to load the data. That will be a lazy argument will be doing. So you have multiple argument for a lazy. So in a simple terms, if I have a child like this, child class like this, where we have ID and name for a child, and if you're not getting what is this one, please watch the previous video. And this one, when this is a toys, we need to look at the toys. One child have many toys, and we here we put a back populate. Additional to that, we will put a lazy argument. What this lazy do is we need to understand. For this, I given question mark. That means there can be multiple options that we can fill for the lazy. So we will fill one by one. So the first option will be select. What select will be doing, and it's a default method. If I didn't give anything, this will be the default one. Then what is up to is open when I ask. So when I put a argument select on the lazy, simply like this, what it will do is when I require that one, when I require the toys, then only it need to be loaded. For example, we had a child. Say I have a child there. I get it from the database. So we are querying the child. Whoever comes the first. Okay, just and I'm just now if I need the toys of the child, what I need to do is child dot toys. So there's okay toys. So what it will do, this will be querying the child. Okay, but the toys class or the toys box will be closed here. Okay, the child box will be open, but the toys box will be closed. And when we are going to call the toys, now the toys box will be open. That's the difference. Okay, I hope you get the first argument. It's a default argument, and what it do, when I ask only, when I call the function, when I call the argument, then only it's going to load the data. That's it. Okay. Now we have the second method. Second method is join. Join. It's in the name itself, bring everything together. So here on the select we said bring whatever, like when I ask, here we are saying bring everything. So only change when I defining this relationship, here it will be changed like joined. Okay, and what it will do, if I execute this query, it will have the child box open and the toys box will be open. Okay. Okay, I hope you get the difference. On select we will get when I ask, on join it will be by default, it will be opened. And the third argument is dynamic. Okay, it's less like depends upon what you need. Okay, say it's a magic search box in our terminology, magic search box. So only thing is changing here, only the lazy argument is changing. Here it will be going to dynamic. That's only thing you're going to change. And what is exactly changing here? So I'm going to write this query child. Okay, this will be getting the child information. Child box will be open. Now I need a specific toy. Okay, that means the color need to be red, for example, or the price need to be more than 20. So how to get that? If I use joined operation, I need to iterate through the child object. This object I need to iterate. If I select also, I need to iterate it. But if I use the dynamic operation, I can say I have a searcher which will be child dot toys. So it will be become a query object. Searcher will be becoming a query object which has the toys information and as well as the child information. Now if I need a red toy or red toys, what I need to do is searcher dot filter, and if I have toy dot color argument, just put as red. Okay, how to write these kind of queries we will explain in the next video, where we are going to handle the session manager or SQL statements. Okay, dot or. Now this is how the dynamic will be working. And there is the fourth argument, subquery. Okay, it is used for batch loading. I don't want to load everything in a one go. I need to load it batch wise. Say if I have a relationship defined like this one, toys, and I say it's a subquery. Now say here we only take the only one child. What if I need to take the 3 child instead? So it will be child session dot query. I need to go for the child class and I will limit with 3 dot out. So it will be getting 3 childs, right? Now if I need to handle like each any child toys, when I need to access any child toys, uh, how to handle this? If I go with select, it will be a multiple query. So it will be taking the first child and go to the database, executing again. If I join the operation, it will be also like the child and toys box will be coming together and I need to iterate to it. It will be a complex logic. Dynamic also, we don't need any searcher kind of thing, right? We only need to get the toys. So then the subquery what we'll be doing is get all the toys in just one go rather than going multiple times. If I need to get a child 1 toy, so just I need to do is child of 0 of toys. Here we load the children's information. And now if I call the toys, get toy information of all the children. Here it will be executing a query. Here also it will be going a query. Here it will be multiple query. Here also it will be multiple query. Here we don't like can't do this. Here we have 2 queries instead of multiple queries. One will be getting the child and one will be getting the toys information. So if I need to get the child 2 toy, what I need to do is child of 2 dot toys. Okay, there is no parenthesis here. So there is no query here. It's already loaded. That's how the subquery works, the batch loading. Instead of going multiple times, it will be coming to one time. And the final argument in this one, it will be selecting. Select in. It's a modern smart loading technique. Okay. Now it's similar to subsquare, but it's a faster method. That's only doing the same of subquery, but in a smart and efficient way. Okay. Okay, now we get say 5 arguments: select, join, dynamic, subquery, and selector. Select is when I ask to open, then only it will going to open. Join will be bring everything together. Dynamic will be magic the search box, like if I need to do any searcher operation in the field, then it will be dynamic. And subqueries and smart selecting will be a batch loading technique. Okay, now we will go for a example, a real world example. Then we will see where I can use lazy, where I can use these other arguments. So let's go to an example. So what I'm going to do is I'm going to create a table here, table.py. So similarly what we done is I need some import and a declarative base. Okay, what these all things are doing you will get when you watch the previous video. Okay, now I have okay, so I have say ID and name common for everything. Okay, ID and name will be common just to be safe. Okay, ID and name will be common. Now class toy, okay, we will start from child just from inheriting from the base, and table name children. Okay, then only additional argument I required is age, which is mapped int, mapped column. Okay, now we have class toy and it's a base, and it is a table name will be toys. The additional argument I required is color, price and child ID, and it will be like this. And I have set a foreign key to the child class dot ID. Now we will create a different relationship styles to compare. Say first we will go for a class. What is the first method we get on this one? Is a select. So we will create a child select, which is inheriting from the base, and I have a table name children. Okay, I have a spelling mistake here. Children select. Now I need the argument. Okay, so here we set the ID and name, so only the foreign key relationship I need to set a lazy select and the map to toy select, because toy select is not created yet, so that is showing error, and I have a select lazy here, and I'm not creating any back population now. We keep it as a simple one. Now we will create a class toy select base, and the table name will be toys select, and we will create a child ID here as a foreign key. Okay, that's only thing we will change. Now similarly we will create for joined and dynamic. So I will copy this. Okay, this will be dynamic. Okay, just go for join first. Joined. This will be joined. This is also joined. And this will be toy joined. This will be select not join dot ID. Then we have, okay, here we need to change it to lazy loading. That means load the JSON toys same time with the join immediately. Now join is completed. We will go for dynamic. Okay, D will be small, here it will be dynamic. Okay, it will be dynamic. I made some errors there. We will fix that. Dynamic when I copy paste, and it will be children dynamic. Dynamic. Okay. Now join operation, it will be toy joined, and it will be toy dynamic. Is that good? Okay, I hope you get it. Now we will go to our main by, where we will going to get a couple of things. We will take it from here. Okay, so session maker I required, an engine from the part 1, and from part part 3 dot tables import. I required base, all the tables, child select. Okay, then I will say import part 3 dot tables as tables. Now we have engine. Now we need to create the tables and the engine. Tables dot base dot metadata dot create all bind the engine. So it will create all the tables we defined there in the database. Now we need a session. I call as a local session. Okay, I don't require from there. I will create here session maker, and it's also going to be an engine. Now session local session. Okay, now I have a function to create a test data. Going to create a test data function. I will go through this. This need to be tables dot. That's only thing. Okay, I have a child called Emma, and I added Emma. Get the ID. To get the ID, I created. For getting ID, I committed it. So this need, I'm adding 3 toys for Emma. So it will be okay. This tables dot select toy select. Now we add that one also. Now we will create another child called Jake. Tables dot save, and I committed for the ID. Now I will create for 2 toys for Jake for the join data operation. For the dynamic operation, I create another child called Lily, and create some magic data. Okay, I use ChatGPT to create this data rather than coding from my side. Okay, that's why the import issue is coming. Okay, and we created a test data. We create one student for the select operation, select lazy part. We create one child called Emma and attach 3 toys for that. For Jake, we attach 2 toys for the joined lazy part. For dynamic part, we created Lily as a child, and we created 4 toys for that also. And we committing and adding to the database also. Now I'm calling this function create test data. Now first thing is the lazy part, load when we access. So what I'm going to do is I'm getting Emma, the first child. Okay, this is a lazy part. So I'm getting Emma, and this will be tables dot child select. This will be tables dot child select dot name equal to Emma. This is how we query. We have the table. We will filter that table with the name. Okay, you can use the ID also if you know the ID. Here we can put ID. ID is there. Name is there. Okay, whichever you required, that you can put it there. I'm going with the name, Emma. So we got the name, and if I try to access the toys, so this will be the database query will be happen here. We will see what is happening there. We will make the echo thing true. Okay. Now what I'm going to do, I will execute this and show you what is happening. So I'm going to the engine and I'm echoing to true, and I created a P2 database. For this we will create multiple data for this because we are calling multiple times the data create when we are going with this one. So I'm going to execute this one. Nope, there is no. Okay, toy select is already defined meta instance. Okay, we made a mistake. Okay, toy select. Okay, here we didn't change. Yes, we didn't put the color. Okay, let's put the color argument also. Okay, here we put, but forgot to copy here. Now we will execute again. What is the column color is not relation, does not exist. To select. To select, we add color. Okay, what is problem there? Okay, the got the problem because the table is already created, and without this one, if I go to the database, I will log into my database, localhost -h, sorry, -u, should be Postgres, -d, it will be P2. So it will ask me the password. So if I select star from toys select, so there is no column name. Either I can alter here, or I can just delete the table and drop the table and create it again. So I'm going to drop the table. Drop table toys select. Drop the table. Now we will create this. Okay. Okay, that's happening for the same also. So we need to create for the joined and dynamic also. Joined and dynamic. Now I will execute it again. Okay, so we forgot to add the price also. Okay, we could add the price. Okay, that is only required for dynamic. Okay, for the query parameter I add the price here. Okay, let's drop the tables again. Select dynamic join. Okay, drop the tables, and I'm going to execute it again. Now if you see, there is too much log is there, so we will see what is happening because we are echoing true, so that's why it's showing this one. So it's creating an engine and creating all the logs, and here we can see that toy select table is created, toys join is created, dynamic is created. For other tables it will be already created, so it won't show the SQL statements. So then we can see we inserted Emma to the table and returning her ID, the child ID, and committed it. Now we will insert G. Okay, and for the G we will insert the toys. For the Emma, already toys is there, and like that only. Now what I need to do here, we can see created the test data, getting Emma, so it will be select this one and parameter like is Emma. So you can see the SQL statement. Now if you see, there is only the ID and the children name is loaded, but if I try to access the toys, you can see it going to get the toys there only. That's the difference. Okay, now what I'm going to do is I'm going to create another table, another database for the other demonstration. So I will add the dynamic loading and the joined operation here for the code, and I will explain what I done there. Okay, now we will go to the next one, which is joined, lazy joined. So we will query the joined operation where children name is Jake, and there is no database query going to here. We will see that, and then we comes to the dynamic part, tables.dynamic, tables.dynamic, children dynamic. Okay, and this also tables.dynamic. Now on dynamic side, we will getting the name, and we will create like lily.toys will be an query object. Note that data, we will see the type there, and we will get all the toys here. So all the toys here, and then if I try to filter it, that also will be possible, which is not possible in the joined or select operation. And we are just filtering with the price, we are just filtering with the color, and then count query does not know all the toys. We will see that. So first I need to change the database name, which is to p3, and then I will execute this. Okay, it's finished. So we will start from the Emma one. Okay, getting Emma, we already see that. Now accessing the toys. Now we will come to the joined operation. And join, when I try to query, you can see there is a left outer joint is happened. Select children ID, toys ID, toys color, where children name is Jake. So there is toys there. There is no database query happening here. If you can see here on the Emma side, when we are trying to access, there is a query executed. Here there is no query executed, just loaded at the same time. And on the dynamic side, we will getting the lily. You can see it will be also as simple query as such. So there is no join operation happen in the dynamic side also. Now if you see, it will be an query object. There it was a data, here also it was a data, here it was a query object. Now if you see, when I try to access it, means all the toys, it executed. Here you can see, when on the dynamic I tried to call all, then it is going to execute all the toys with the child ID which is given. Okay, now it has a doll, block, book and crayon. If we check the data we set for doll, block, book and crayon, that will be all the toys will be loaded for that particular child. Then what is the next argument we given? Price above 15. So you can see there is another argument is going. The argument is where ID is whatever the ID the child have, and the price greater than whatever the value we given, and it's only selected blocks. And if I try to call the pink, it again go to the database and execute the query. And if I try to go to the last one, the count you can see 4, which is because the child ID is there. It's a count object query, means select count star query, but it only loaded for the particular child. That's the difference. So select and dynamics work same way. It's going to execute in whenever we call the filter, but dynamic is more we have more control what is the data we need. Okay, we like, and select in the other option, subquery and select, you can try it yourself with the same examples. Okay, now we will see we have these much options where to use when. And if I go to, okay, I will write here. Okay, I will minimize this terminal. Okay, now when to use each. The first one is select. Okay, where to use the select? One thing is small relationship. Okay, like 1 to 10 items or something like that, only you need to use the select. And by default select will be there. You need to more careful when you are creating the foreign key relationship. And second thing is sometimes accessed relationship, not frequently accessed. Okay, okay, where I made mistake. Okay, accessed relationship, not frequently. And default choice when you are unsure, that will be for the select. For joint operation, it will be small but frequently accessed relationship. Okay, and then we have always need related data. Okay, and the most important thing what I will do say is N+ query problem, and that is our bonus point. We will explain what is a N+ query problem. Avoidance. Okay, now we will go to the third one, dynamic. Here it has a large collection. Here we said 1 to 10. Here we can say 100 plus. Then other one is need filtering or searching or pagination. For those we can use that dynamic lazy loading. And third one, don't always need the always need all the items. Okay. And the last one I can say subquery and selectin, which is both are going together. You can use subquery or you can use subquery or selectin. Both are working in a same way. This is when say loading multiple parents that each have children. So it can be a like you need to query all the tables, or like you call all the users. Similarly, you need to call their child also, like user settings, user profile, those need to be. And here we said n plus query problem avoidance with a small frequency. Here you can, for the large one, you can use this one, avoid n plus query problem. And third one, say you will access all the relationship, you are sure about that, then you can use subquery or selectin. Mainly these 2 points are required. Now what is an n plus query problem? Say, so now we will say about n plus query problem. N plus query problem. N plus query problem. What is it? Say we have something like this one. We have set the lazy to select. Okay, lazy part to select. And when I am going to say getting the children with 5 children, this will be one query. And if I need to print the toys, how you are doing, like for child in children, I will print say child have this many toys, something like this. Okay, this will be a query. So how many queries will be going to run? It will be, this is 5 and it will be 5 query it will be going to run. So actually we only need to run 5 query, but it's run an extra query here. We run an extra query here. This will call an n plus 1 query problem. We can interpret it in 2 ways. Well, a data can be loaded in one query. We avoided that and we load the data using additional n queries. So it will be an n plus query problem. Or we need to execute n queries, but we need to get an additional 1 query. Both are same meaning only. So we only need to execute 1 query, but in order to get all the data, we executed additional n queries. So how to solve this? So for that, we need to set the lazy part to selectin or subquery. Selecting or subquery, where we will do the same, or it will be one query. And if I try to do here the same method with explanation that we are already seen, or for the only the first child, it's going to execute the twice join operation. So it will be only running one query here, only one query. Totally, we will finish the operation in 2 queries. You can see here we use 6 queries, here we only use 2 queries. Now, for as a mind map, you can say select memory trick, which is I remember. Okay, memory trick. First is select. Give me the box. I will open later. Second one is join. This will be give me the box, but books with toys already net. Third one is dynamic. So dynamic, give me a toy or multiple toy. Give me a toy, also give me a toy finding robot or finding robot. Okay, last one is selectin or subquery, which is we are using in the production grid system, and it will be simple like if you're getting many boxes, get all at once. That's it about the lazy part. I think it's also been 252, nearly more than 30. So that's why I'm said I will do it in another way, because we already split the SQLAlchemy into 2, and this will be another half an hour course. So by these 3 videos, you will able to create an SQLAlchemy model, a database model that you can use in your application. So we completed the engine, we completed models. Now we need to handle the sessions. How to handle the sessions, we will talk about in the next video. Till then, stay tuned. Please subscribe, like and share, and we will see in the next video. Till then, bye.